All right, so now we've gone over a bunch of Ubuntu commands. Let's get into ROS. So big things with ROS is first, why, right? Like what the heck is ROS? Why do we use it? Well, so ROS is a file system and a message passing backbone, right? So when you're working on, for example, one of these Marine Robotics Club projects. So on the WAMV, we had a low-level system and a high-level system. The low-level system each had 10 packages. The low-level system probably had 10 packages. High-level system had about 10 packages. Each one of those packages may have between 1 and 10 scripts. Each one of those scripts might have multiple classes. And so you get into these very complex environments very fast. And so what ROS provides you with is a way to organize it all, right? I think that a lot of people, especially in OE at FAU, you're real, you might have taken a class in C, but chances are it's Arduino and it's MATLAB. And so with Arduino and MATLAB, the traditional paradigm for making a program is one file, right? You have one file and that's got everything under the sun that you could need in it. And what happens is, if you're reading from a pressure sensor and just outputting that over an RF string, that's not bad, right? That one file is just fine. But if you're trying to have a control system for a robot, a perception system for a robot, a path planner for a robot, acoustic system for a robot, you're going to have a 15,000 line file that only one person can work on at a time, that chances are only one person knows how to work on it. I see it flashing in and out. I'm not sure exactly why. If you're losing connection with the screen, just know I'm not using it right now. Just listen to the sound of my voice. So we use ROS as a package management system, right? We use it to, excuse me, make sure that we can distribute these projects between a team. And we also use it as a message passing backbone. And at the core of that is the publish and subscribe paradigm. So when you have and those two things go hand in hand. Let's try to, there we go. So when you have your robot, right? Let's say that it's a ground robot, and a simple one. And you've got a compass, and you've got a GPS, and then you have your motor controllers. You have your command output. So the way that you would use ROS is you have a package that the only thing that it does is gets the information from your compass. You have a package that the only thing that it does is get your information from your GPS, and you have a package that the only thing that it does is it writes information to your motor controllers. And what that does is it makes your system modular, so that now if you swap out your compass, you don't have to change anything other than that one file and that one driver. And the way that you do that is with topic names. So what we can see, and we're going to go to ROS Publisher. We're going to straight up go through the ROS tutorials. So the first thing that I tell people when they get started with the Marine Robotics Club and they want to work on code is go through the ROS tutorials. The reason is because it's full of great information. And if it's worth it to go through them, it takes a week, spending 2 hours a day, But what happens is it gives you a certain level of vocabulary of what's going on inside of ROS, a certain idea of how these things interact together, and it, make sure that this is something for you, right? Like to put it simply, robotics are tough, right? It's a tough field. And if you're having a very tough time going through the tutorials, then you need to find different ways to overcome it, right? And finding, instead of diving headfirst into a project, you might, want to get some help on it. Make it a collaborative project. I think that experience is definitely the best teacher, but banging your head at a wall can be very frustrating and disheartening. So go through the tutorials, because a lot of the questions and issues that you might have, they're going to pop up. And if you have an issue with the tutorial, do a search for it. Look at the forums. ROS is used everywhere, and now the open source community has really put out a lot of good information on how to interact with any issues you may have. So we're going to toggle these line numbers, and so the first thing that we do for ROS, we're going to go into programming, actually here. We're going to go into Seminar 1, and now when you want to use ROS, like I said, the first thing that it is it's a file system, right, or structure system. So we have to set that up. So we're going to make this directory, and it's going to be called catkin _WS. So ROS works with catkin workspaces. Just the name of what it is. Still don't know what catkin means, but here we are. So catkin workspace, I'm going to cd into that. I'm going to make another directory called source, or src, and then I'm going to cd into source. I'm going to type in catkin init workspace. And so you see that it's created the symlink. Now what this has done is made this cmakelists.txt file, and it's also, and that's it. So now if we go up one more folder and we type catkin make, we now have a build and a develop folder. So just like that, we have a ROS workspace. So, however, Linux doesn't quite know where that is yet. So what we're going to do is go back into our .bashrc, and we're going to go down to the bottom, and right under where we added that other source command, we're going to source the develop folder where we just were. So it's going to be source tilde slash, for me, seminar 1 slash catkin workspace slash devel slash setup.bash. So this is super important. If you don't have this line in your .bashrc, in a little while from now when we go to run this program, ROS is not going to have any idea where it is. So Control X, Control Y, enter. Now, who remembers what I said about when .bashrc runs? It runs only when you make a new terminal. So we just edited that file, but we didn't make a new terminal window. So what that means is if you go right back into that terminal and you start editing it and you say, oh, well, I sourced my .bashrc, but Linux isn't finding my package, well, that's because you didn't finish the process. And it's going to catch you. Every single person in this room, it's going to catch you. If, it caught me, it still catches me 100 times. So you can, so the story goes, you can type source tilde .bashrc, tilde slash .bashrc. I've had mixed results from that. For me, I found sometimes it works, sometimes it doesn't. Without a doubt, the easiest thing for me is just open a new window. I know that now it's done. So we have our catkin workspace. We told Linux where that catkin workspace is. Let's make a ROS package. So now I can just type ROS CD, because now we have all of these ROS tools. And what it'll do is it'll bring me right to my workspace. Now, I don't want to be in devel. I want to be in source. So I'm just going to hop over there. I'm going to type catkin create PKG. Now I'm going to type the name of the package, which this is going to be pub and sub. So ROS standard dictates that the names of packages are in this style where it's all lowercase with spaces in between words delineated by underscores. Drives me crazy. I like camel case, but if you make your package names camel case, it'll yell at you and it'll give you, it still works fine, but it's just going to give you warnings. So I call this pub and sub, and now we're going to tell it to depend on ROS CPP. I think that's it. Just to make sure, I'm just going to take a quick look at the GitHub. Okay, never mind. So we're going to go with ROS CPP. So now we have the package called pub and sub. So we're going to go into pub and sub. See, remember I typed catkin and knit package and nothing else. And so what it generated is the source folder, the package.xml, the include folder, and the cmake lists.txt. So if we take a quick look at those, the cmake lists.txt has what the package name, ROS CPP, which is what we typed it as a dependency, and then a bunch of configuration parameters if we're going to be using our own, if we're going to be generating messages. And also, it's going to have the name of your executable. So that's going to be down here. So what we're going to do right now is, to make things easy, I'm going to take this guy, I'm going to go here. So if you're following along, go on down to build, right? So there's a couple of different subcategories. You can see the stars, this and that. Now, to be honest, I'm definitely not the strongest person in CMake, but the good news is once you do this once, you really don't have to do it from scratch again, right? Anytime that you make a CMake list for whatever your first project is where you're really linking stuff and making new, making new message types and linking that all together, just use that as a reference, right? You don't have to have this stuff memorized. So we don't have a library, but we are going to have, I don't think that we're going to have dependencies, but we are going to want to add this executable, and the executable is, we have two executables actually. We're going to make this listener.cpp, and we're also going to say source/talker.cpp. Now where this says project name _ node, we're also going to change that, and the executable is going to be in the name of the package, which was pub and sub. Okay. So there are install options, but I don't think that we're going to need to run that. So now we need to make those files. We made a talker, and we made, we told the computer to compile a talker and subscriber, which is a publisher and a subscriber. So listener, and talker is what we have them labeled as. So now I'm going to go to source, and here is where I'm going to go back to the tutorial, and I'm going to just grab, this is the talker, if I'm not mistaken, the publisher, yep. So I'm going to say nano, I'm in source, and it's talker.cpp, Control-Shift-V. So now I'm going to go through this quickly because the only thing that's different in this file than any other C++ file or any other C file is a couple of lines. So this is boilerplate, ROS init, ROS node handle. You're going to see that in every single ROS script. And all that does is it sets up the message passing. Beyond that, what you're going to see is this advertise chatter. So this is probably the most important line for the publisher because what it does is it specifies what the message type is. In our case, it's an STD messages string. It also specifies what the name of the topic is. So when we make the listener, we have to make sure that it's listening for a message type STD messages string on a topic chatter. So before, when I was talking about if you have a compass and you have that driver for it and you change out your driver, the only thing that you have to do is change that file. Well, this would be what you don't change, right? Maybe you interface with that driver differently, but as long as you have the same message type and the same topic name, it interfaces with the rest of the system completely. And there are, at this point now, you know, if we look at ROS STD messages, there's 24. So this, you know, it's taking a little bit to load, but you can see there's, come on. So these are all the different type of standard messages, but there's also so many more. You could look at, let's say, instead of standard messages, nav messages, right? So you have ROS nav messages, which has more complex types like, let's give this a second to load, but odometry and path and these amalgamation messages that are, you know, as you use the scientific approach for robotics, you'll say, okay, well, a state message, you know, if I want to control a robot, it needs this information. Well, that information is going to be things like your pose and your twist. And so this is, you know, it's able to define an entire 6 degree of freedom vehicle, you know, appropriately. Sorry. So able to define an entire 6 degree of freedom mathematically and transport all that information around in standard ROS messages. And everything that you can do that's in a standard ROS message, do it. And if you think you need a custom message type, sleep on it, because those ripples will come back, right? Because when you use ROS standard messages, you get to use ROS standard packages. So that odometry information you might want to have connected to some other package that you don't want to have to develop from scratch. If you use a standard message, you can do that. So then the last thing is just the loop rate. So you can specify also how fast you want the loop to run. So this is saying do it at 10 hertz. All right, so now we have talker. So we're going to go back to the subscriber. Okay, so the subscriber is a little bit different, and there's two parts to a subscriber. It's the actual setup for the subscriber and then the callback. So ROS works in a non-blocking way. So what that means is that this loop is being told to spin. So what's happening is it's in this main loop, and it's essentially while one, right? It's just spinning indefinitely. And every time that it does, what happens is it checks to see if there's any new information on this chatter topic. If there is new information, it performs the callback. If there's not new information, it doesn't do anything. So that way you don't waste resources. And so then this chatter callback is being told here to just output the message in the string. Simple. So ROS info is what you use for debug statements. Printf, fprintf, cout, all that stuff are now gone. Of course you can use them, but again, if you use the ROS standard stuff, you can use more powerful things that you'll encounter down the road. So your 4 standard ROS output levels: info, debug, warning, and error, which is really nice because you don't have access to that level of granularity in cout or fprintf. What that means is that if I do, and we're actually going to show all of them. I'm going to do ROS debug info warn error. We'll show what all of those different ones do. So we're going to save, select yes. Now we are going to go back to the root of the Catkin workspace, and we're going to build. We're going to cross our fingers. I hate to see it. I mean,
You have the same message for all the different ROS types.
all that's doing is printing. It's a print statement. But so what it's saying is in function main, multiple definition of main. And okay, so that's why these need to be in separate packages. So now what we're going to do is use some of our other tools that we learned about before. So we're going to do Catkin init workspace, Catkin create package, and we're going to say talker, and that's going to need ROS CPP, and we're going to do Catkin create package listener, and that's going to need ROS CPP. So now we're going to move from pub and sub source, the name was listener, and that's going to go to listener source, and we're going to move pub and sub source talker, and that's going to go to talker source. Now, the last thing is we're going to want to copy from pub and sub source So we are going to copy from source pub and sub CMake lists. That's going to go to source listener. We're going to copy source pub and sub CMake lists to source talker. Now, we are going to have to go in here. Now, I said before, we have this pub and sub, which is the project name. That's not the project name anymore. It is listener, and we can use that control W to make sure that pub and sub is not anywhere else. And we press Control W, so we see that it is there in this add executable. So, as we changed before, this is listener, and so we're going to delete the talker. And we're going to do the same thing with talker. And delete listener. Okay, so it's still trying to build out pub and sub, which we are no longer using. So rm-r, pub and sub, gone. So we use all the things we talked about, definitely all part of the plan. Okay, just kidding. Famous last words. So, what I'm going to do okay. So, what I believe is the issue. Okay. So, when we created these, the only thing that we added as a dependency was ROS CPP. So we're going to add a few more things. So if you look at package.xml and got in there with nano, what we can see is that there's just Kaken and then there's ROS CPP is really it. So I'm going to hit Control X and Control U, Control K, Control U, pardon me, and then Control K and Control U. So we're going to add STD messages. I think we need ROS console, but I'm gonna add that just in case. So there's one more place that that we need to update that. And that is in the CMake lists. Okay. All right, so I added a package that I wasn't sure about, and we don't need it, and it's actually not supported in this version of ROS. So ROS console is out. Come on. All right, so clearly I'm forgetting something. Okay. Sorry, guys. So, little gotcha. It's honestly, it gets me like every damn time. It's just, so what I was saying before, do it once and then copy. I just copied it from the package that I had. So it's this. It was this target link libraries and the add dependencies. It just wasn't quite, that wasn't configured exactly correct. Bad news for you guys is you had to sit while I stared at my screen for 10, 15 minutes quietly. Good news for the people at home is I'll be able to edit this out. And with some movie magic, no one will have ever known. But so you could have. Now's your chance. So point being, what we need in our CMake list file really is only just a couple of lines. So we can go ahead and get rid of a whole bunch of good stuff. If there's something that is, not commented out, we're just going to leave that for right now. But really, these 3 lines are the only things that you need to add, where it's you add the executable, which is the name of the executable that you want, and the path to that executable, target link libraries. This specifically tells it to use the catkin library. So that way it knows how to build. And really this add dependencies is something that I just put on all of them. So I remind myself if I do have dependencies, but there's really none that are in use right now. So now again, if we hit it with catkin make, we see that there's a warning because of those generate messages, but no worries there. So now we get to run our programs. So go ahead and open up 2 terminals, and I'm going to use ROS. So first, ROS pack find listener, and it auto-completed so we know that it's there. Similarly, if I say ROS pack find talker, it auto-completed, it knows that it's there. So what we can do is we start and we say ROS run the name of the package, and then you just hit tab. It'll just automatically run or show the executable, but the command is ROS run, then the name of the package, then the name of the executable that we specified in that CMake file. Press enter, say, oh no, failed to contact ROS master. So you always have to have a ROS core running. If you use ROS run, you have to run the core manually. If you use a ROS launch file, which is a way to run either a single executable or multiple executables with a single command and with specific parameters set, that automatically runs ROS core. But in our case, we're not using that, so we just type ROS core into a new terminal, and we can see that this is now outputting messages, which means that this is publishing. So now, when we go to our remaining terminal, and we say ROS run, listener, and listener, now we see this. So what we see here is we see our 3 different colored messages. So there's white, there's yellow, and there's red. Now, if you recall from that program, what we actually had is, we're going to go to seminar, catkin, and we're going to look at cat source listener source listener.cpp. What we see from this is that we had 4 printouts. So you might say, well, how come it's not doing one of them? Well, it is, but what we can do is we can set the level of the console. So now what this means is that when you're developing, when you first write a program, you might want to have 101 debug statements, but you don't want those once the program is finalized. So what you do is run RQT logger level, you press enter. Now what this shows is all of the different nodes that are active and you can set what the logger level is for each one. So this is listener. Right now it's set to info. So if we press debug, so now it'll actually show all 4 of them. And a recursive, and we can actually see that there is, even another one, that this is actually a ROS one, that I believe it is yelling at us for having all 4 of those lines be just about the same. Now, if you want to go to just error or just error, right? Now this, if things are just about final, you might want it on warning or error level, and that way you're only having the information if something is going wrong. So and also sometimes it's just nice to have 4 different colored texts in your terminal window, right? You might be working on something and have 2 different types of information that you're printing out, and you can use ROS warn for one set and use ROS debug for the other set, so you can see green and yellow, very clearly in the midst of everything else. And we just set it back to info, and we get all 3 of ours back again. So now what we've seen is a publisher and subscriber. We've seen RQT logger level, but there's actually a few other really useful RQT tools as well. I'm going to run the listener back up, and I'm going to say RQT graph. So what RQT graph does is it shows us all of the active nodes and what the topics are that connect them. So now we see that we have talker going to listener, and it's going over topic chatter. So now this command, when it's just these 2 nodes, big whoop. But when you think, like I said before, we have 10 nodes for the low-level system and 10 nodes for the high-level system, all of these different topics going all over the place, this automatically generates your system flow map, right? So with one command, if you say, hey, I have this node that's a subscriber and it's not getting data. Well, if you look at RQT graph, maybe it's not connected, right? Or maybe it's on the wrong topic name. So another great ROS command line tool is RQT info. And so, or I'm sorry, not RQT info. So ROS, RQT underscore graph and RQT underscore console underscore, or RQT logger level, right? RQT logger level and RQT graph, 2 super powerful tools. Another one, RQT plot. So now what this gives us is exactly what it says. So now we can't really plot because of the way that this is strings, but you can imagine if this was numeric data that was getting printed out, we could subscribe to it and plot it real time with just running a terminal command. Finally, and I know that we're coming up just about on time. Before we get there though, I do want to just hit a few other useful ROS command line commands. So ROS topic and everything that comes along with it, right? So with ROS being a message passing backbone, being able to know what's going on with your messages and debug them, very important. So when you have ROS topic, if you hit double tab, again, you can see all of the different things that you can do. And so ROS topic BW stands for bandwidth. And we actually at RobotX this past competition, we really had to look at what the bandwidth was of our system because we saturated our router. So you can see on a per message basis which one is taking up how much data. So if we say BW chatter or BW / chatter, so what it does is it subscribes to it and then it does the calculation and it's telling me that it's 200 bytes per second, right? In this case it's nothing. But if you're streaming HD stereo vision, and, you know, a 64 channel LiDAR, those numbers become way higher. So that was ROS topic BW. ROS topic Echo, also really powerful. It's just a command line version of the subscriber, right? And so we could have set up this publisher and subscriber way easier and way faster in the command line, but it's nice to have the scripts, you know, as your basis for whatever your next project is. But if you just want to set something up quickly, you can do ROS topic pub -R, set that loop rate of 10, and then let's say we're gonna set it to STD messages int 16, and we'll say number. Put this the other way actually, /number. STD. Come on, give me the autocomplete. And okay, so this is the format for it.